exponents, when you divide, copy the base, subtract the exponents, and you know this, right? When you raise, you multiply, and when you root, you divide. With logarithms, it's exactly the same thing, but backwards. So, because this is the inverse of exponent. So, if you have, for example, the logarithm, they don't have to have the same base. So the logarithm base 3 of 4, for example, plus logarithm base 3 of 8, what this is telling you is this is one exponent and this is another exponent. What do? You copy the base and if you're adding, what does it mean that you were doing? You were multiplying, right? Because if you're adding the exponents, these represent exponents, that means that you were multiplying. So what you do is copy the base and you're multiplying. You are going the other direction. Okay? Same thing if you have, let's say, logarithm 3 minus. This one represents an exponent, this one represents an exponent. So if you are subtracting them, it means that originally you were dividing. So you've got logarithm base 3, 4 divided by 8. Yes?
But why is it in the first one you put the 8 first and then the 4?
Because it's commutative and it's the same thing. But fair enough. Fair enough. Because multiplication is commutative. It wouldn't be the same thing here, right? Yes. Same thing if you raise. If you have logarithm base 3 and you have a 4 here and an 8 here, what are these two doing? What is the 4 doing to this? Multiplying. So when you multiply, it means you were raising. So this would be 8 to the 4.
Oh my God.
So you see that it's exactly the same thing, but in the other direction. So how do you use this? May I erase? Yes, everyone?
Yes.
I only got one yes.
That was mine, right?
Aha. And such excitement. It just makes my skin makes it warm.
It's a special yes.
No, it's a yes.
Okay, here we go. So we've got logarithm base A 4 plus logarithm base A of 6 equals logarithm base A of x plus 4. So what do?
That's multiplying.
It's multiplying because you were adding, so it's 4 times 6, which is 24, right? Equals logarithm base A of x plus 4. Since I have logarithms, same base on both sides, gone away, inverse logarithm on both cases, so I've got 24 equals x plus 4. And you can easily solve that. 20 equals x.
Can you do one with the square root?
With this one, there's no, it's not in logarithms.
Okay.
It would be raised to the 1/2. So that's as far as you go in logarithms, this one. As far as I know. Maybe there's a mathematician watching me out there and he's gonna go and comment and I don't know. Okay. Do you want me to do another one or is it pretty clear? Oh, I need you to see. No, so far nothing strange here. Maybe later on. Okay. What do you do? Completely changing the subject here.
Uh-oh.
Do you remember inverse functions?
Yes.
You do?
It's like the arctangent.
No.
It's a weird thing.
It's leaving x.
It's leaving x by itself and then changing the letters
Oh,
over
yeah.
again. So if you had something like this, y equals x squared plus
Oh my god.
2.
No more
This would
letters.
be y minus 2 square root equals x. So inverse function would be y equals x minus 2 square root. Remember? and that when you stick one into the other, you get x as a result? Well, now they're going to give you two functions, and you have to check to see if they're inverse or not. What do? You stick one into the other and see if you get an x as a result. So let's do one. Show that f of x minus 1, let's see, f of x equals 1/3 of x minus 3, and g of x 3x plus 9.
Uh-oh.
Show that they are inverse functions. So what do?
You solve it.
How?
You
You do f of g of x, and you do g of f of x. And they should both equal x. If they do, then they're inverse functions. So let's see. This is f of g, so it's 1/3 f of, I'm gonna write the long way, but you can skip a couple of steps if you want to. Minus 3, which would be 1/3 of 3x plus 9 equals
Minus 3.
minus 3. And this would be a x plus 3 minus 3. This one equals x. This one checks out. Now let's do this one. This would be 3 times f of x plus 9, right? Which is 3 1/3 of x minus 3 plus 9. This is x minus 9 plus 9. This is x. Therefore, they are inverse functions. Easy, right?
No,
No, why not? Be specific on why it's not easy.
because it's math, man.
Fair enough. But did you understand what to do?
Yeah.
It's long, I admit it. But it's really simple. It's adding and subtracting, basically, and multiplying. So we're good?
Yes.